This video is on the objective. Perform and interpret a hypothesis test for the mean with population standard deviation unknown, right? Sigma's unknown, so it's going to be a t-test for a mean, not a z-test. And this is using technology, using your calculator. All right, so I'll be using the TI-84 Plus, Silver Edition. As you've seen in other videos I've done, your TI-84, 83, very similar functions, very similar features. And this is number one. I'll do maybe a couple videos on this objective. So let's look at a question from your Newton Alta homework related to this objective. So again, if you want to see how they're doing things, click on more instruction, look at their videos, their notes, their examples, and hopefully those help you. So here, a popular charity used 36% of its donations on expenses. An organizer for a rival charity wanted to quickly provide a donor with evidence that the popular charity has expenses that are higher than other similar charities. All right, the organizer randomly selected 10 similar charities and examined their donations. The percentage of the expenses that those 10 charities spend on expenses is given below. So it says use a TI-83, 84 plus, 84, whatever. To test whether the mean is less than 36%. Identify the test statistic t from the calculator output rounded to 2 decimal places. All right, so here we're actually given the sample. All right, so I'm going to run through the beginnings of the hypothesis test, though. All right. On some paper, explain what certain things mean. Let's go to the calculator here for a second. So here we're doing a test about a mean, right? So what does this mu represent in this particular example? So mu is the average percentage of expenses for these charities, right? The average all right, so this is the average percentage of expenses spent by charities. Right. So average percentage charities spend on expenses. I'll word it that way. Average percentage all these charities, all similar charities, spend on expenses. All right, and what they're testing here, remember a claim or a belief is identified. And we're testing the claim that the mean percentage is less than 36. That's what they're asking us to, right? It said it right there in the paper, right there in the assignment. It says, test whether the mean is less than 36. All right. So we're testing this statement. And then hypotheses are formed, right? H0, the null hypothesis, the alternative hypothesis. This claim does not involve equality, so that's going to be in the alternative hypothesis. Then the null is the opposite of that. Right, the mean is greater than or equal to 36, right? 36% spent on expenses. But remember, we're only using the equal one, right? We assume the equality, right? We're going to assume that the average percentage charities spend on expenses is 36%. Right. Okay, and then the significance level alpha. Now they didn't mention an alpha here, so usually if alpha is not mentioned, you can reasonably use a 5% significance level in most tests. All right, and then we have a sample. All right, now I'm just going to stop here. We'll stick to I'll make sure that we have these listed off. The sample was given here, right? This person took 10 similar charities and saw that, oh, this one charity spends 19% of their money on expenses. This charity spends 25% of their money on expenses, then this charity spends 31% of their money on expenses, etc. All right. Let me enter this into a list in my calculator. All right. Let me pull the calculator up, and hopefully you remember how to enter lists of data. Hit the stat button, right? Hit enter on edit, and I'll just enter these numbers down list L1. So again, 19, 25, there's only 10 of them, so I'll just do all of them in the video here. 31, 20, 41, 32, 26, 21, 9, and finally this last charity spends 24% of their money on expenses. Okay, so now I get out of here, and they're asking us to just have the calculator perform a t-test for us. Because again, here's a case where sigma is unknown, right? Notice they never mentioned what the population standard deviation is. So this is going to definitely be a t-test when I do a test about this in population mean. All right, so remember where z-tests were in the calculator? The t-tests are in the same place. So I go stat, over to tests, and you see how number 1 was z-test. This is when I was doing a test for one population mean, and sigma was known. Scroll down to number 2, t-test. This is when I'm doing a test about one population mean, and sigma is unknown. So I hit enter on that. Now, it's going to ask you, do you have a list of data, which I do here, or just the statistics? If I go to stats, see that. Do I know the sample mean? Do I know the sample standard deviation? No, I don't know that stuff. I don't know that stuff right now. They didn't give me that. They just gave me a list of data. So I'm going to go to the data part. All right. Now this first line under that says mu0. Now mu0 is what's the population mean assumed to be from the null hypothesis. So remember what that was. That was 36. All right. This is the mu0. Right, so the calculator coming back up here. So mu0 is 36. Where was your list of data? Well, I already had it down list L1. If you have it down L2, just hit second then 2, or L3, hit second then 3, whatever. But I have it down list L1. The frequency, there is no frequency list here or probability list. So just leave this frequency as 1. Every single value is counted 1 time. Then this next line is, what kind of a test is it? We see here it's a left-tailed test. Look at this is basically telling me what does the alternative hypothesis look like. Is it that mu is not mu0, less than mu0, greater than mu0? Mu0 is 36. Well, we have mu is less than 36. We're testing that the mean is less than this, 36%. Right? So I move it to that and then go calculate. And look at all this stuff that's given to us. Well, they tell us what the alternative hypothesis is up top. The t equals negative 4.08 blah blah blah. That's the test statistic for our sample. That's what they're asking for on the problem, the test statistic. This p is the p-value. And you see the p-value is like 0.1%, very small. And if the significance level was 5%, I would be rejecting the null hypothesis here because the p-value is less than or equal to alpha. And then it gives us the sample mean, right? The average of all 10 of those numbers was 24.8, and it also gives us the standard deviation for that sample and the size of the sample. But those numbers aren't as important as the test statistic, and especially the p-value, right? Because again, you just compare the p-value to alpha and then make your decision. Do you reject the null hypothesis or not? All right, so going back to the website, back to the problem, they want the t-score. What's the test statistic to 2 decimal places? Well, according to this, that'd be negative 4.08 negative 4.087, so negative 4.09 if I rounded to 2 decimal places. So negative 4.09. All right, that's the first thing they asked for. Right, great work and all that, and they showed you, they did the same thing I just showed you. I don't know if that's all of it, and that is. Okay, so I'll come back and do another video on this question, because this next question asks you a lot more. All right, asks you about rejecting the null hypothesis and all that. But again, it's a pretty simple setup. Enter your data, go to that stat, tests, and then t-test, right? Because again, sigma is unknown. Make sure you got the right alternative hypothesis mentioned, the right null hypothesis assumed mean, and then your test statistic and p-value will come up automatically. It's wonderful. All right, so hopefully watching me do this and maybe looking at the more instruction help you when you're working on this on your own. And thanks for watching.